Trigonometry, Chapter 1, Trigonometric Functions, Section 3, Trigonometric Functions, Video 8, Trigonometric Functions of Quadrantal Angles. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. As we progress, we will learn the exact values of trigonometric functions of specific angles. To do so requires the coordinates of a specific point on the terminal side of an angle. In this video, we will examine the trigonometric functions applied to quadrantal angles. Recall that a quadrantal angle is an angle whose terminal side lies on the x or y axis when the angle is drawn in standard position, such as 0 degrees, no rotation, where the initial side is the terminal side, 90 degrees, which is 1/4 of a rotation, 180 degrees, which is half a rotation, 270 degrees, which is 3/4 of a rotation, and of course, 360 degrees, which is one complete rotation. We can also continue rotating beyond 360 degrees and generate angles coterminal with the ones we've just saw. We can also rotate in the negative direction and similarly generate angles coterminal with one of these. Since every quadrantal angle's terminal side lies on an axis, grammar, it will be relatively easy to pick a point on the terminal side. Since the choice of points is irrelevant, as we mentioned in the previous video, we choose points whose coordinates contain 1 or -1. For example, find the values of all 6 trigonometric functions of 90 degrees. Well, let's pick a point on the terminal side of 90 degrees. For simplicity, we'll pick the point 0, 1. To calculate the r, we need to use the formula, but it's just 1. Now, we didn't really need to calculate it because r is the distance from the origin to the point, and the distance from 0, 0 to the point 0, 1 is just 1. So if it's evident what the distance is, no need to calculate r. Now we have x equals 0, y equals 1, and r equals 1. Calculating the values of the trigonometric functions is now straightforward. Here's our definitions, which you still need to have memorized. And here they are with 0 substituted for x, y substituted for 1, and 1 substituted for y, 1 substituted for r, and 0 substituted for x. And as usual, we clean up some of these fractions, but there's 2 fractions that have an issue. Notice 2 of the ratios have a 0 denominator. This means these functions are undefined for this angle. The remaining values can be simplified as either 1 or 0. And I'll write U and D for undefined in this case. In general, for any quadrantal angle, a point on the terminal side will always have 0 for one of its coordinates. For example, if the terminal side is on the positive x-axis, then it will always contain the point 1, 0. If the terminal side is on the positive y-axis, then it will contain the point 0, 1. Negative x-axis contains the point -1, 0. Negative y-axis contains the point 0, -1. And in the right column, we have a list of such angles, coterminal within a given row, whose terminal side is on these half axes, if you will. Now, since each of the points contains a 0 coordinate for either x or y, there will always be trig functions that are undefined at quadrantal angles. Specifically, if x equals 0, because your terminal side is on the positive y-axis or negative y-axis, then any trigonometric function whose denominator is 0 will be undefined. Well, who has a denominator? Excuse me. Any trigonometric function whose denominator is x will be undefined. Which trig functions have a denominator of x? That would be tangent and secant. Tangent is y over x, secant is r over x. And similarly, if y equals 0, then any trigonometric function whose denominator is y will be undefined. This occurs when your terminal side is on the x-axis. And which trig functions have y in the denominator? Cotangent and cosecant. Cotangent is x over y. Cosecant is r over y. Now, I don't expect you to memorize all this. You can. I would instead memorize the definitions of the trig functions, which you need to do, and understand why they are undefined for various quadrantal angles. If you stop on an axis, your x or your y is negative, and so any trig function whose denominator is that, excuse me, if you stop on an axis, your x or y is 0, which means that any trig function that has a 0 in the denominator, x or y, is undefined. All right, pause the video and try the following problems. I know it's a lot, but this is worth trying. Determine the values of all 6 trigonometric functions for the following quadrantal angles. Pause the video, give it a try. Trust me, this is worth the time you invest. If you haven't paused the video and tried it, I would do it now because this is a very good exercise to undertake. That being said, here's your warning. Solutions in 3, 2, 1. Quick commentary. Notice that sine and cosine never show up as undefined because they never have a denominator of x or y. Their denominator is always r. But tangent and secant are always undefined because their denominators are always x at the same time. Cosecant and cotangent are always undefined simultaneously because their denominator contains y at the same time.